This is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 7-6 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to factor out a common factor. So the main goal of this section is to be able to factor expressions that are written in this form. Okay? Remember, this form is called the standard form of a quadratic. And what we have learned to do with the standard form of a quadratic is when this a value is 1, we have learned the double bubble method of factoring, where you break it into two sets of parentheses, find what multiplies to c that makes b, right? Now what we're doing is we're dealing with situations where there's something other than a 1 in front of the x squared, all right? Now there's a few things that we also need to analyze. So the first thing when I look at this example problem is it doesn't start with x squared. It's starting with x cubed. Now, luckily, all of these have an x in them. So what this means is that I could take out a GCF including an x, and that's going to lower each of these exponents to start looking like that standard form. Another perk that we could see here is that these are all divisible by 3. So before I factor this up, I'm actually going to factor out the GCF of 3x. So what that ends up looking like, 3x cubed divided by 3x is x squared. 15x squared divided by 3x is 5x. And negative 18x divided by 3x is negative 6. And remember, if you ever want to check yourself to make sure you're not making any mistakes, you could redistribute that 3x to the parentheses and it should take you back to the original function. So now that I've factored out that GCF, now you can see that this middle part is totally factorable. So what I'm going to do is I'm going to set up a little t-chart, and we're going to go ahead and break this up into the double bubble. Okay? Now don't forget that 3x that we pulled out, he kind of just sits out here like a puppy. Okay, he follows us along but doesn't really do anything else to help with the problem. Okay? So remember, factoring here, because there's a number 1 in front of the x squared, this allows us to use a double bubble method. Okay, so that tells us I need an x and an x. This first sign, this plus sign, falls down into my first set of parentheses. And then I look at this second sign, which is a negative 6, and it tells me that I need opposite signs within my parentheses. And it also tells me that I'm going to be subtracting when I go to do this table. So now I'm finding the factors of 6 that subtract to make 5. So if I list off the factors of 6, I have 6 and 1, and 3 and 2. And when I subtract them, I get 5 and 1. So this top option here with the 6 and the 1, those subtracted to make the 5 that I need for my b term. And remember, the bigger number goes with the sign that fell down. So the interesting part about this is that we did factor once and then we factored again. So we actually factored it twice to get it into the factored form. And so that's actually something that's really common when we're dealing with factoring, is you might need to take out a GCF and factor, or soon you're going to see what's called the difference of squares, where you factor and then factor again. So just be aware, sometimes you have to factor more than once. So you want to check your solution that you get and make sure it's factorable. All right, so now let's try it. So for part A, I have x squared x in a a constant term. So it's already in the standard form of a quadratic. But what I'm looking for now is I'm looking for a GCF that might be numerical. So 5, 35, and 50, those are all divisible by 5. And so I'm going to factor that out of this trinomial. So 5x squared divided by 5 is x squared. Negative 35x divided by 5 is negative 7x. And 50 divided by 5 is 10. And now that I've factored out that GCF, now I'm going to try to factor this stuff using the double bubble method because there's a 1 in front of the x squared. All right, so again, because I have an x squared in a linear term, I know that I have x and x. My first sign, that negative, comes down. When I look at my second sign is a positive, and that tells me my parentheses have to match. And it also tells me that I'm going to add when I go to do this table. So I'm going to go ahead and I'm going to try to find the factors of 10 that add to make 7. So if I look for factors of 10, I know 1 and 10 and 2 and 5. And if I add those across, I get 11 and 7. So this bottom set of factors is the set that I'm going to use. The big one usually goes with the sign that falls down, and the small one gets filled in. So now this is my fully factored form. All right, let's try this one more time. So on this one, you can see my exponents. I have x cubed, x squared, and a linear term. So that means that I definitely need to factor out an x to make it into a quadratic. And then if I look at the numbers, 6, 30, and 24, I know that 6 goes into both 30 and 24. So I'm going to factor out a 6 as well. So if I divide by this GCF of 6x, 6x cubed divided by 6x is x squared. 30x squared divided by 6x is 5x. And 24x divided by 6x is 4. I'd say we were 6x full at factoring out the GCF. I'm sorry, that was bad. Alright, so now that we factored out the GCF, let's go ahead and we're going to use the double bubble to take this further. Our goal at the end of most of these problems is we want what are called linear factors. So we want the stuff that's in parentheses or whatever polynomials we're left with to only have x to the first. That's our end goal. So the reason why I know that I want to try to take this further is I have an x squared. Okay? So here's my double bubble. I have a square and a linear term, so I know I need an x and an x. My first sign falls down. And then I look at that second sign. So because this second sign's a plus, I know I need matching signs down here. I also know that I'm going to be adding on my little factoring table. So I am looking for the factors of 4 that add to make 5. So the factors of 4 are 4 and 1 and 2 and 2. And if I add down, I get 5 and 4. So the set of factors that I want are 4 and 1. So there we have it, guys. That is how to factor out a common factor. Until next time.